In the last module, we studied how to use truth tables to determine the validity of arguments in propositional logic. Now, this method is technically infallible when applied correctly, but in many, many instances, it can be very tedious to actually use and apply. For example, if an argument involves 5 different simple propositions in it, then the associated truth table would have to contain 32 different rows that we would be working with. Indeed, every additional atomic formula doubles the size of the associated truth table, and so this doubling phenomena can make things incredibly difficult to actually use. Lucky for us, there is a way around this problem, and it is what we call an indirect truth table. Now, an indirect truth table allows you to avoid all of this tedium, the tedium of having to deal with every possible line in the argument. And what it does essentially is offer a shorter and faster method for testing for validity. Now, to construct an indirect truth table, we start with the assumption that the argument is in fact invalid, and then we see if we are capable of confirming this hypothesis by getting the form to produce the result that all of the premises are true and the conclusion is false. Now, the easiest way to explain this is to just jump right into an example. And let's start here with example number 1. So here's an argument. The first premise says it is not the case that P and Q is true. The second premise says P, and then our conclusion says Q must be true. So the first step in dealing with an indirect truth table is to start by displaying the inference of the argument as if it were in a normal truth table, identifying all the various terms, the premises, and the conclusion, but without listing all the possible truth values for the simple propositions in the argument. So in this particular case, what we want to do is set up the truth table like we normally would, and on the left-hand side, list all of your particular simple terms. But notice what we're not going to do is sit there and sort out every possible truth relation between these terms. Normally with 2 terms, we'd have 4 different lines to work with. We'd have true on top, true to false, false to true, and false to false on the bottom. But we're going to just leave that blank as a sort of frame of reference for doing the indirect truth table. So again, step 1 is to simply list all of your simple terms on the left-hand side, but without listing any of the truth values. From here, the process is pretty much the same. The next step is to simply place all of our premises and the conclusion in order on the truth table with lines dividing them. Notice our first premise, premise 1, it says it's not the case that it is P and Q. And of course, where I place this little P1 is right above the tilde, since that is my main operator. And again, I think this is a very useful tool. It's not something you'll see in the book, but it's a smart way of sorting out your objectives by simply identifying each of your main operators as you go. And of course, the next step is to separate this premise from the next one, and we do that by a slanted line, a single line. And then the second premise, P, goes on the line, and of course, since P is the only thing, I'm going to place my little P2 right above it. Now that we've placed both of our premises, we separate the conclusion by putting a double slash on the bar. And then, of course, the conclusion goes at the end. So our next step is to realize that the goal we are aiming for is to do everything in our power to find a way to make this argument produce the result that all of the premises are true and the conclusion is false. And if in fact we can show this, then we know it must be an invalid argument. So notice our goal. What I've done here is simply place the true and the falses above what I'm trying to accomplish. So I want to see if I can make the conclusion false with the result that all of the premises will be true. And so my main operator, of course, is what I'm looking at. And so I placed a T above both of the premises main operators and a false above the conclusion. Now, since our goal is to find a way to make this argument produce this result so that all the premises are true and I get a false conclusion, the first step is to lock in any of the simple variables that can actually establish that for me. So if there's anything that you know has to be false or true in terms of your letters, that is your simple terms, then simply mark those down. Now again, the goal here is to make the first premise true, the second premise true, and our conclusion false. And notice, in order to accomplish this, if we just start at the conclusion, Q would have to be a false statement in order to get this arrangement of things. So notice that simple term Q has to be false or my conclusion can't be false. And so simply place a false underneath that. And notice what this accomplishes for me in the argument as a whole. Since in the conclusion Q has to be false, it would have to be false everywhere in the argument. So we know what our conclusion has to be, and we're finished with that. And notice that means we also know what Q has to be all the way through the argument. So we can start placing falses everywhere they need to be, go find every other Q in the argument and simply place a false underneath it. So we're going to deal with all of these simple terms first. That's our first goal. And of course, once you know the total truth value of Q, what you can do is go to the left-hand side and place a false there as well, so that you know when you're finished dealing with all your simple terms. We're done with Q, we don't have to worry about anymore. And so we place on the left-hand column the truth value of Q underneath that so that we know what we've accomplished. Now we still have to deal with the second term here, the P term, as a simple proposition. And of course, this one's going to be pretty simple to sort out as well. If we look at the second premise, all we get in the second premise is P as a statement. And of course, in order to make that true, P is going to have to be true. And so we wanted to stick a true underneath the P there. And what I've done essentially is established that in order to accomplish the goal I have in mind, which is to get all of my premises to be true and the conclusion to be false, I know that premise 2 requires P to be true. And so I can just lock that particular variable in by making it true. So at this point, you just want to backfill for every single variable that is P and simply put it true underneath it. And of course, you want to put in the left-hand column P, since we know what the truth value of P would have to be in order to accomplish this. And notice what's happened here. Once I've assigned all of my simple terms truth values, then we just have to go back to the original argument here and work through every single operator to see what happens as a result. If when I'm finished, because of these operators, given the truth values I've assigned to P and Q, if the result is that all of my premises are true but the conclusion is false, then I know it's invalid. And if it turns out I can't produce that result with these truth values locked in, then it would have to be a valid argument. Now at this point, I just need to solve for premise 1. We've already sorted out what premise 2 has to be in order to make it true, and we've already sorted out what our conclusion has to be in order to make it false. And given that we've ascribed necessary truth values to all of the simple terms, the only thing left to us is to work through the operators. So if P is true and Q is false, what does that tell us about premise 1? Well, notice first of all, the first thing we have to sort out is P and Q. And of course, if P is true and Q is false with a conjunction, then that conjunction itself must be false. And so we know that the conjunction is false. We throw a false underneath it, and then we move on to the final and main operator. So what we have here essentially is a conjunction that is being negated. If the conjunction is false and I negate it, then of course the result is pretty obvious. Negations always do just the opposite, so this makes it true. Notice what we've accomplished then. Given that we know P would have to be true and Q would have to be false for even the possibility of this argument to produce the result we're looking for, which is all the premises are true and the conclusion is false. And given that the operators in premise 1, using the truth values of P and Q that have been assigned to them, produce a result that it's true, we end up with exactly what we're looking for. true, true, false. And of course, what that shows us is that this original argument must be an invalid argument. If an argument is even conceptually capable of producing this result, then we know it must be an invalid argument, because a valid argument could never ever produce a result where all the premises are true but the conclusion is false. So what we've done basically here is simply reverse engineered the process of our truth table so that we can just try to produce the result of it being invalid. If we succeed, then it's an invalid argument. If we fail, then it would have to be valid. So let's take a look at a second example, and this time we'll aim for one that ends up being valid, so we can see how that plays off against the invalid version we just saw. So what we get here is a very simple argument. It says in premise 1, P and Q, premise 2, P, therefore in our conclusion, Q. So once again, what we want to do is set up a truth table like we normally have, but without assigning all the possible truth variables to our terms. So we set P and Q, since we only have two terms, off to the left-hand side of our truth table. And then we start to fill in all of our premises. Now premise 1 says P and Q, and notice the main operator of this is the and so we want to take that, write it on the truth table, separate this from the second premise with the slash, and then we place our second premise, which is just the variable P, on the truth table, separate this with double slashes from the conclusion, and then we get our conclusion at the end. Now notice what we have here is a very simple argument, and again, keep in mind what our goal is. What we want to do essentially is try to see if we can make this argument produce a result where both of these premises are true, but the conclusion is false. And so the first step is to just find anywhere in the argument where we can concretely lock down the truth value of any of our simple terms, P and Q. Now, very easily, we can deal with our conclusion first. Q would have to be false in order to get a false conclusion. Since the only thing that is our conclusion is the variable Q, and since we want to make our conclusion false, then Q has to be false. And so we can ascribe the value of false to the letter Q. And then we can just start running through the rest of the argument. Find every Q all the way through the argument and ascribe the value of false to it. Since we know Q has to be false, it has to be false everywhere in the argument. And notice that this means we've sorted out the truth value necessarily of one of our variables Q. And so just write that on the left-hand side so you can keep track of what you've already done. Now, of course, the second premise is going to have to be true. Just like with the conclusion, there's just one term there, P. And of course, if I want to try to make that premise true, and since it's just P, then P has to be true. And so we know the truth value of P. We can ascribe that to every P in the argument all the way through. So just run through the entire argument, find every P, and put a T under it. And of course, then notice we have assigned truth values to both of the terms in the argument. Every simple proposition has been locked down with a necessary truth value if we stand any hope at all of achieving the goal we set to ourselves, which is to produce a result that all of our premises are true, but the conclusion is false. And so now what we have to do is work through any of the operators that are left to us using the ascribed truth values of the simple terms. And in this case, there's just one thing to deal with. That's our conjunction. And of course, a conjunction where one side is true but the other is false has to be a false statement. And so notice, using the truth values for P and Q that we've assigned necessarily, what we discover is that premise 1 ends up being false. And of course, if premise 1 is false, what does that tell us? Well, it did not produce the result we're looking for. Given the necessary use of true and false for P and Q, the result of that premise is that I end up with a false premise, a true premise, and then a conclusion. And since I'm not even capable of producing the result where all of the premises are true but the conclusion is false, this has to be a valid argument. Now let me warn you in a weird sort of way about one of the strange things that we deal with when dealing with indirect truth tables or truth tables in general. When I get the result that I'm aiming for, that is technically a bad thing. If everything ends up true, true, false, that means it's an invalid argument. And of course, when I don't get what I'm looking for, that's actually a good thing. That makes it a valid argument. And somehow that usually feels weird. It can be a little confusing at first, but keep in mind what your goal is. You want to try to produce both premises as true and the conclusion as false. So let's keep walking through some examples, and we'll try to get more and more complex as we go, and eventually we'll look at some of the more quirky parts of dealing with indirect truth tables. But let's take this example. Notice this one says in premise 1, it is not P and R. Premise 2 says P or Q, and the conclusion says Q or not R. So notice in this instance, we have three different variables, P, Q, and R. And if we are going to construct an entire truth table, we would need 8 lines to deal with this. And again, it starts to get pretty clunky and unwieldy very quickly when you start to do this. But what happens with an indirect truth table is we can skip most of that garbage. So the next step in this, of course, once we've laid out our terms on the left-hand side of the truth table, is to just start plugging in all of our premises. So premise 1 says not P and R. And of course, the main operator here is a conjunction, the R. And so it doesn't hurt to put a little symbol right above it so you know what you're looking at. Then we want to separate that premise from the next premise with the slash. Premise 2 simply says P or Q, and so we place that on the line after the slash. And then we want our double slash so that we know that we're separating all of our premises from the conclusion. And of course, the conclusion goes at the end. And our main operator with conclusion is also just the wedge, or the disjunctive statement. So now we've set up the truth table. The next step is to recognize what our goal is. And of course, what our goal is to make both of our premises true and the conclusion is false. And it doesn't hurt to just put a little true and false above each main operator so you know what your goal is. Now, it turns out the best starting place for this particular example is either with premise 1 or it is with the conclusion. And in this case, we'll just start with the conclusion. And of course, what our goal is to make this conclusion false. And to do that with a disjunct, that means both sides of the disjunctive statement, the Q in this case and the not R in this case, would have to be false for it to be false, because a disjunctive statement is false only if both disjuncts are false. But of course, in order to make the second disjunct, the not R, false, what I would have to do is make R true and then negate it. So notice R has to be true and Q has to be false, because I want to negate the R to make it false so that I get a false disjunctive statement. And then once it's negated, I now know what the truth value is for that entire disjunct. I get false to false. And of course, in a disjunctive statement, when both of my terms are false, then it makes this a false statement. And so the total value of this premise with the ascribed truth values of Q being false and R being true is now false. And so what we want to do is take these terms, Q and R, and plug them in anywhere they go in the argument. So go look for any Q's and make them false, look for any R's and make them true. And then you want to go all the way to the left-hand side and plug in the truth values for those terms on the truth table there so you know which terms have already been dealt with. So we've dealt with Q and we've dealt with R. We know Q has to be false and R has to be true in the argument in order to accomplish the goal we've set ourselves in the conclusion. Now, in order to make a conjunction true, it turns out that both terms would have to be true. So it's pretty much just the opposite of a disjunctive statement. Now, we already know that R is true, and so all that's left to us is to figure out how to make P or not P true. And that, of course, implies what? To make this side of the conjunction true, that means P would have to be false so that when we negate it, it becomes true. So P is false. We can now negate it. That becomes true. And now we've sorted out that entire side of this conjunction. And then, of course, we know that the conjunction itself with the two terms being true has to be true. And so we've simply placed a true there, and we've sorted out that entire premise. We've made premise one true, and we've made the conclusion false. So we're most of the way there. Now, of course, we've also figured out what the truth value of P has to be. P has to be false. And so go on the left-hand side and plug in the term where it belongs, and then find P anywhere else in the argument and plug it in. Now at this point, we've solved for every simple proposition. So all that's left for us to do is work through any operators that remain on the truth table. And in this case, what we have is simply a disjunction. I have false on one side, false on the other. That makes that particular disjunction false. And of course, notice what that means. This means we did not achieve our goal. Remember, what we wanted was to try to make everything that's a premise true and the conclusion false, but we couldn't get that result using the necessary truth values for all three of our terms. The second premise ends up being false. So we end up with true, false, false. And since we didn't produce that result, we know it must be a valid argument. So let's try another example, and this time we'll get more and more complicated as we move along. So here's a rather messy argument, one that I'm not going to bother reading to you. The next step in this, once you have this argument all laid out in formal symbolic terms with your premises identified and your conclusion identified, is you want to set this up on a truth table. So in this case, we have 4 different terms. And of course, if we wanted to use a full-blown truth table, we would need 16 lines, and things start to get messy very, very quickly. So again, the advantage of an indirect truth table is that it allows you to skip all of the tedium of placing little trues and falses on 16 lines under every single possible term and operator in the original argument. So instead, what we want to do is simply lay out our truth table with all 4, in this case, of our terms on the left-hand side listed in order, P, Q, R, and S. And then we need to start laying out the argument on the truth table in order. Premise 1 is this mess. Now notice in the end, this entire long, messy statement is just a conditional statement. It's an if-then claim. The antecedent is a mess of its own, and the consequent is just this negated term S. So we want to lay this out here, identify your main operator, and then simply separate this with a slash. So we place a slash to separate this premise from the next premise. And then we lay out the premise, the second premise, in order, P and Q and R. So we place a double slash on the end of the line here in order to separate the premises from the conclusion. And then we finally place the conclusion at the end, the one easy thing in this entire argument. So what is our goal in all of this? Well, notice again what we're trying to accomplish is to see if we can force this argument to produce this result, so that premise 1 and premise 2 are both true, given their main operators and all of the truth values ascribed to the terms, and the conclusion is false. If I can produce this result, then I know it has to be invalid. If it's valid, it could never produce this result. Now, the obvious starting point here is just going to be with the conclusion. Since I want to make the conclusion false, and since the conclusion is just the letter S, S would have to be false in order to accomplish this goal. So simply place a false underneath S, and then we're pretty much finished with the conclusion. We've achieved that one milestone or marker, and so we move on from there. And of course, since S has to be false, go find S anywhere else in the argument that you can find it and make it false. And then, of course, we want to go to the left-hand side and start checking off the boxes. Since we know S is already false, we can write false underneath that. We now just have to deal with the remaining 3 terms. Now, notice premise 2 is going to be pretty simple. And one of the reasons this will be simple is that everything in there is an and claim, and I want to make it true. And since with an and claim or a conjunction, the only time it can be true is if everything in there is true, this sorts it out pretty simply. If it were a disjunction and I wanted to try to make it true, that becomes problematic because a disjunction is true in multiple cases. It's only false in one. So as a pretty good rule, when you're trying to figure out where to start in an argument, go look for the things that will give you one and only one possible outcome. So in this case, of course, in order to make premise 2 true, I know that Q and R would have to be true in order to turn that portion of this ultimate conjunction into a true statement. And of course, P is going to have to be true too. So we know Q and R is true. That makes that entire conjunction true on this side of that premise. And then, of course, in order to make the ultimate operator, the main operator here true, P would have to be true, and this other conjunction is true. That sorts it out for us. So we know in the end we can make this true by simply ascribing the truth values of true to P, Q, and R, and then premise true has to be a true statement. And of course, what that does for us is assign the truth value to every single term in the argument. P, Q, and R have to be true, and we know S has to be false. And so what we want to do is simply fill in everywhere where you see a letter the appropriate truth value. Go find P, Q, and R, put a T under them, and on the left-hand side, fill in all the blanks so that we know we're finished with all of our simple terms. Once you're finished with all of your simple terms, the only thing left to do is sort out all of the operators. And of course, notice if we just start with this one, we can kind of run through all the negations. Every single term, P, Q, R, and S have been negated. So take the truth value and simply flip it. P was true, it becomes false. Q was true, it becomes false. R was true, it becomes false. And S was false, so it must become true. So now we know the truth values of all of these negations, and so now we just need to run through the rest of it. And of course, the order of operations here is to deal with the wedge in parentheses between the Q and the R. And once we're done there, we need to move to the and between the P and the parentheses. And then finally, we can get to our main operator, which is the if then. So we just have to work through things in that particular order. So of course, notice the or here, the disjunction, if it's false on both sides, then it has to be a false statement. That is in fact the only time that a disjunction is false if both disjuncts are false. So we know that that disjunct is false, and so we can move on to the conjunction. Now notice the conjunction has false on one side and false on the other, which is all of this stuff on the right-hand side, the Q and the R that's been negated. And false to false gives us a false for the and. And of course, then we're finally to the main operator for this. I have on one side false and on the other side true. False to true with an if then is going to be a true statement. The only time a conditional statement is false is if I have true on the antecedent side and false on the other. False to true renders it a true statement. So we know this is a true statement, and of course, if you just take a look at this, what you know is that I get true, true, false. That is, I met the goal I was aiming at. I produced exactly the result I was trying really hard to get, which is to make both premises true and the conclusion false. And when I achieve my goal, what that means is it must be an invalid argument. And as awkward as that feels, like you won, you did it right, it is nonetheless an invalid argument. You've now proven that. Let's take a look at another example. Example 5 here. So this one says, in premise 1, P or Q. Premise 2 says, if R, then not P, and if S, then not Q. And the conclusion that's drawn is not R or not S. So we have 4 different terms again. And if we had to work through this in a full truth table, we would need 16 lines to sort out this mess. So what we can do with an indirect truth table is set it up like we would a truth table, and then simply list our 4 simple terms in this case on the left-hand side. And then we just need to start plugging in our premises. Premise 1 goes first. Separate that from premise 2 with a single slash. Lay out this long, complicated mess for premise 2. Notice in the end, premise 2 is just an and claim. It's just a conjunction. Each conjunct is its own independent conditional statement, but in the end, the main operator here is just that dot. We want to separate both of the premises then from the conclusion with the double slash, and then throw the conclusion on the end. And of course, our main operator with this conclusion is a disjunction. Now, my goal, of course, is to make both premises true and the conclusion is false. And it's a really useful basic tool to simply place a true or a false above each of the main operators accordingly. So I want to basically make the wedge here for premise 1 true, the dot true for premise 2, and the wedge false for the conclusion. Now, the obvious starting point in this case is going to be at the end, because with the disjunction, in order to make it false, I need both terms to be false, both of my disjuncts. And of course, notice my disjuncts are both negated terms, which means the simple term R and S would have to be true. And once they're true, I can simply negate them to make them both false. And from there, I can prove, or at least show, that the conclusion needs to be false as a result. So if I ascribe the truth values to R and S as true, and then negate them to false, this conclusion would thus be false. So given these distinct truth values, we know that we can make the conclusion false. And of course, what we want to do is simply ascribe the truth values wherever they go. Since we know R and S both have to be true, go look anywhere in the argument for an R and an S and stick a true underneath them. And then go to the far left-hand side of the truth table and simply put true underneath, so we know the truth values for R and S have been sorted out. Now we need to deal with P and Q. And of course, the best place to start in this case is not going to be premise 1, because notice for premise 1, if I wanted to make that true, I have too many options, right? To make that particular statement true, P and Q could both be true, P could be true and Q could be false, or Q could be false and P could be true. The only time I would know something for certain would be if they're both false, it becomes false. So a disjunctive statement on that side where I try to make it true is not going to be particularly helpful. A conjunction, on the other hand, is going to be really helpful, because a conjunction is only true if I can make both sides true. And so, of course, what I want to do here is simply go find out how I can make both of these true. And if you stop and think about this for a minute, what I need to do is make both of these conditional statements true. Now, a conditional statement is false only under the condition that the antecedent is true and the consequent is false. Now, given that the antecedent has already been assigned the value of true in both cases, that means I need to make the consequent on both sides true. But of course, since they're both negated terms, I have to make the simple term P and Q false so that I can negate them and then make them true. Now that's a lot, it's a little complicated, but if I make P and Q false, what happens is I can simply negate them so that they're both true. And then of course, what I have is true to true with conditional statements on both sides. And under those conditions, I actually get exactly what I'm looking for. Both terms are now true. Both conditional statements can be assigned as true so long as we ascribe those appropriate truth values. P and Q need to be false. And of course, if these two terms, both of my conditional statements are true, then we know that this premise could be made true. And so we've established this. We can make premise 2 true pretty much in the only way by ascribing the truth value of false to P and Q. So at this point, you just want to backfill. So we know that P and Q have to be false. Go find any P and Q left in the argument at all and simply ascribe false value or truth value to each of them. So under P and Q, put a false. And then, of course, we want to go to the far left-hand side where all of our terms are and put a false under both P and Q so that we know we've addressed those terms. And of course, now all of our simple terms have been assigned a truth value. P and Q are false. R and S are true. There's nothing left to do here except work through any remaining operators. And in this case, there's just one to deal with, and that's a wedge under premise 1. And of course, when you have an either or claim where both sides are false, then that has to be a false statement. And so what we've accomplished here is actually quite useful. We know that given these ascribed truth values, all of which are necessary in order to produce in the conclusion a false result and in premise 2 a true result, given these, we know that we don't get true, true, false like we're looking for. The result, of course, is when you don't produce that, we know it must be a valid argument. So let's take a look at another example, and we'll get more and more complicated as we move along here. So here's a particular argument. I won't read the whole thing to you, but basically we have this rather complex argument, and what we need to do is take each of our premises and our conclusion and lay it out on a truth table. So we have exactly 4 terms, once again, P, Q, and R and S, that goes on the left-hand side in order, simply to identify all of the simple terms we need to address. And then we need to just start plugging in all of our premises and the conclusion on the truth table. So premise 1 here, which is just in the end a conditional statement, goes first. We separate this from the second premise, not P and Q, and we place this, not P and Q. Notice this is a conjunction, and we want to identify that. And then, of course, once we've laid out both premises, we want to separate those premises from the conclusion with the double slash, and then we simply lay out the conclusion on the end. And the conclusion here is S and R. Now, notice our goal, of course, is to try to make both premises, in this case, true, and the conclusion is false. And it doesn't hurt, once again, to place the little t or f above each of the main operators so you know exactly what your goal is. In all of the examples we've seen up to this point, we've been able to start simply with the conclusion. But in this particular case, starting with the conclusion is going to be quite problematic because, of course, what we want to do is try to make the conclusion false, but we're dealing with a conjunction. And a conjunction is false in many possible ways. The only time it's true is if they're both true. So if either side is false or if both are false, it would end up being false. And that leaves us too many options. So notice there are 3 possible ways to get this to be false. I can have S be true and R be false. I could have S be false and R be true, or I could have them both be false. And any one of these alternatives would produce the result that there is a false conclusion. So this is not useful for us, and so we can't really start here in a functional way. Starting with a conjunction in the second premise, where I'm trying to make it true, on the other hand, is going to be quite easy because a conjunction is true under only a single possible circumstance where both conjuncts, that is each term on each side, is true. In every other possible arrangement, it must be false. And so this one is going to be actually the place to start. And of course, to do this, we need Q to be true, but we also need P to be false because it is being negated. So if P is false, we negate it to make it true. And then finally, we get our main operator, the and, or the conjunction. And if it's true to true, it will be true. So of course, P negated becomes true. And the conjunction, where our 2 terms, our 2 conjuncts, which is not P on one side and Q on the other, if it's true to true, we get this to be true. So we've solved for premise 2, and we also now know the necessary truth values of at least 2 of our terms, P and Q. P has to be false and Q has to be true. And so what we want to do is go look everywhere else on this line and find anywhere where there's a P or a Q and stick under the appropriate truth values. So with Q, we want to make it true. With P, we want to make it false. And again, go to the far left-hand side of the column, write in your truth values so you know that those 2 terms at least have been already sorted out and dealt with. Now notice that hasn't helped us at all with the conclusion. We're still facing the same basic problem, that there are a whole bunch of different ways in which we could make the conclusion false, and there's no way we can lock in concretely what the truth value of S or R might be. So we're going to have to go over here to look for something and hope for the best. Now notice, because the main operator in this first premise is an implication, that is, it's a conditional statement, and if then, That means in order to make this true, all we would really need to do is make sure that R is true. Because if the consequent of that particular statement is true, then in every conceivable case, whatever happens on the antecedent side, the P or if Q then S, no matter what result you get there, if it's true or false, this would still be a true statement. Because the only time a conditional statement is false is if the antecedent is true and the consequent is false. So by simply assigning the truth value true to the letter R, we know that we can make premise 1 true. So we can just set it in there, and then we have to worry about S still. But notice if we can make that true, then what we can do is run through the rest of this. Now notice we know R has to be true, so let's assign the truth value to R in the conclusion, and then also assign it on the left-hand side so we know that R is dealt with. Now if R must be true, then we can actually solve for this quite easily, because notice with the conjunction, the only time that it's true is if they're both true. And if R is true, the only way to make sure that this is not a true statement is to assign the truth value of false to the letter S. So S has to be false in order to make the conclusion false. And then we've accomplished our goal on that end. We're getting pretty close to the end of all this. So we know that the conclusion is false, and we just want to ascribe then the truth value of false to S anywhere it shows up. So go find it anywhere in the argument on the line, and then at the very end, on the left-hand side, place your false underneath that. We've ascribed truth values to every single simple proposition in this, and at this point, all that's left for us is to work through any operators that remain. Now notice the basic order of operations here. The first thing I have to deal with is this conditional statement, if Q then S, because I can't figure out what the disjunction P or if Q then S would be until I know the truth value of if Q then S. And of course, I can't really figure out what the main operator of this premise is until I sort out all of that mess in the first place. So we can start here with this conditional statement, if Q then S. And if we ascribe the truth value of true to Q and false to S, when I have true to false in that order, with a conditional statement, this has to be a false claim. So we know that this particular statement, if Q then S, would have to be false, given the assigned truth values of all of our simple terms. And now we can figure out what the disjunction would be. False on one side, false on the other with the disjunction is false. And so we get a false here for the total value of the entire antecedent of this statement. And of course, now we're working from false to true with conditional, which as we already sorted out a while ago, this has to be a true statement. So the result here is I get a true for my premise, and that's exactly what I'm looking for. So true, true, false does in fact produce the result I want, and that means that this must be an invalid argument. So we've started to see how this can be somewhat tricky and how it takes a bit of thought to sort out exactly where to begin, what you need to do to figure out exactly what terms are things that you can lock into place in terms of their truth values. And so what we need to do next is look at situations where there is no clear starting place, where you're not really in a position at all to determine precisely what terms must be true or false. So let's take a look at this particular example. Premise 1 says P or Q. Premise 2 says if and only if Q, then R. And then the conclusion says P and R. So let's set it up like we're supposed to on our truth table. We have three different terms, P, Q, and R. Put those on the left-hand side and then set up your truth table. Premise 1 is simply P or Q. And then we want to separate that from the next premise, which is Q if and only if R. And again, our main operator there is the if and only if. And then we need our double slash to separate all of our premises from the conclusion. And the conclusion goes on the end, P and R. Now notice what we have here in this particular case. We have two different premises, one conclusion. We've identified each of our main operators. And we know exactly what our goal is. I want to try to get both premises to be true and the conclusion to be false. But if you stop and think about it, there is no good starting place. The problem we have is that in each and every possible case, in both premises and the conclusion, we have multiple possibilities to sort out what could be true or what could be false for each and every one of our terms. So if we look at our conclusion, for example, P and R, it turns out, again, my goal is to make it false, and I could do that in three different ways. I could make this a false statement by saying P is true and R is false. P is false and R is true, or they could both be false. And in this case, in every last one of these options, all three of them, I would end up with the result I'm looking for. So I have no way of knowing precisely and concretely what truth value to assign to P or R based on the conclusion. But the same thing is true with premise 2. In order to make it true, all I have to do is get both terms to match. If they're both true, it's true, Q and R. And if Q and R are both false, it'd be true. So I still have no way of assigning a concrete truth value, a necessary truth value to either Q or R based on this premise. And of course, the same thing is true with our disjunction here. To make a disjunction true, there are a whole bunch of different ways to accomplish this. So I have no good starting place. And so the question is, what do you do under such circumstances where you really don't know where to begin? Well, the answer here is to pick a starting point, regardless of what it is. It doesn't really matter. Just pick one. And then work through all of the possible solutions. You shouldn't have more than 3, maybe 2, but let me show you what this would look like. If we just start with our conclusion, now you could start with the first premise or even the second premise and see if it works for you. But we'll just pick our conclusion and notice there are 3 possibilities here in order to produce the result we're looking for. I can either have P be true and R be false. P could be false and R is true, or I can have P and R both be false. In each and every case, I end up with the result I'm looking for. I can make the conclusion false. And so what I want to do at this point is just stick with all 3 of these lines and run through all 3 of them simultaneously. So I now know that the truth value for the 3 lines I'm working through for P would have to be true, false, false in that order. And so I just want to go ascribe the truth value to anywhere I find P true, false, false on 3 separate lines in that order. And then of course I now know that R has to be false, true, false for these 3 lines. And I just want to go find R wherever I can find it and ascribe those truth values in order on these 3 lines. So if you stop and think about what we're doing here, all we're doing is working through 3 different possible truth tables given these 3 possible arrangements. True to false for P and R, false to true for P and R, or false to false for P and R. And then we just work through all 3 of them and see if any one of these 3 lines is capable of producing the result we want. And again, this is only really necessary when you just don't have a good starting point, when there's no way to lock down anything in the argument concretely. Now at this point, premise 2, or really premise 1, but premise 2 becomes very useful to us because my goal is to make that premise true. And I can do this in every single case by simply putting the same truth relation that R has for Q. Because remember, for a biconditional, and if and only if, it's true whenever they match. So since I need to make this premise true, I now know the truth value of Q would have to be exactly what R says. So Q has to be false, true, false in order, just like we see with R. And now we have all 3 terms defined. So I now know exactly what P, Q, and R would possibly be in all 3 of our possible situations. So now that we know the truth value of all three of our terms, the only thing left to do is to solve for any operators that are left. And in this case, that just means premise 1, which is just a disjunction. So we can go look at premise 1 and figure out the truth value in each of these three different lines. So of course, notice if a disjunction is true to false, it's a true statement. If it's false to true, it would be a true statement. And of course, if it's false to false, it's a false statement. So this is the truth value for this disjunct for all three of our possible relations given the truth values of P, Q, and R. And of course, it turns out that two of these, in fact, are capable of producing exactly the result we're looking for, which is two true premises and a false conclusion, or all of our premises are true and a false conclusion. And that, of course, implies that this is an invalid argument. So let's look at one last example, and then we can be done running through all of this. This one's perhaps a little more complicated than the one we saw before. The basic structure of this argument says, in premise 1, if P then R. In premise 2, we have if and only if S then P, and if and only if Q then R. And then our conclusion says S and Q. Well, we have four different terms, P, Q, R, and S. So we want to set these up on our truth table on the left-hand side in order so we know each of the simple terms that we need to assign a truth value to. And then we just need to start laying out the argument in order, both premises and the conclusion. First premise, if P then R. Notice our main operator is, of course, the conditional statement. We separate this premise from the second premise with the slash. And then we plug in our second premise. Now, in the end, this is just a conjunction. This is an and claim. It just happens to have on each side a biconditional as its conjunct. And of course, we can separate both of our premises from our conclusion with our double slash, and then we throw our conclusion in to end it. Now, our goal, of course, is to try to make both of these premises true with our conclusion to be false. And one last time, it doesn't hurt to put those truth values right above the main operators so you know exactly what your goal is while you're working through this. So once again, we find ourselves in a position where there's just no good starting point. If you look at our conclusion, for example, to produce the result we're looking for, which is to make it false, there are three different options that we could have. And if we go to the first premise, we find ourselves in exactly the same condition. For this conditional statement, the only time it could be false is if I have true to false with the antecedent and consequent. But there are three different options here to make it true, so that doesn't help either. And frankly, this part gets really messy really quickly because there are a whole bunch of different ways in which we could make this possibly true. So what we need to do is just pick somewhere to start. And in this case, we'll just start at the conclusion. There are three different options. We need to run three different lines at the same time for all of these different variables to see if any one of these possible arrangements can in fact produce the result we're looking for. So notice what we get in this case is I can have S be true and Q be false for the first line, S be false and Q be true for the second, or they could both be false on the third. Now, once I've started assigning truth values to my terms, plug them in where they go. So I'm going to stick to my guns on this with the conclusion. I know Q has to be false, true, false for the three lines. S needs to be true, false, false for those lines. And so plug them in under any term you find with those truth values. And then, of course, go to your left-hand column and note this so you know which terms you've already addressed. Now, at this point, we're in a pretty good spot to deal with the second premise, because what I need to do is make the whole thing true, and that means each of these biconditionals need to be made true. Now, a biconditional is true whenever they match, so I just need to take the P and the R terms and match them to the corresponding S and Q terms. So P would have to be like S, true, false, false, and R would have to be like Q, false, true, false, in order to make this entire thing true. So that produces both biconditionals as true statements all the way down, and that makes this entire premise true. So we've pretty much figured out all the truth values of our various terms. We now know that this is solved for as true. Premise 2 we can make true, and our conclusion is false. And we know the truth values of P and R. So P would be true, false, false. R would be false, true, false. Plug them in where they go on the argument and on the corresponding left-hand side of this with each of the simple terms. We've now solved for every simple term, and the only thing left to do is look at our first premise. And so, of course, with our first premise, we have a conditional statement. With a conditional statement, it will be true in every possible situation unless the antecedent is true and the consequent is false. So we're just looking for that relationship, true to false. And of course, notice we find one of those, true to false. That makes that a false statement. The next one, false to true, would be true. And then false to false would also be true. So what does this tell us? Well, the truth value for this conditional statement for these three lines in order is false, true, true. And now I just want to go look at each individual line by itself and see if I produce the result I'm looking for, which is to make premise 1 true, premise 2 true, and the conclusion false. Well, it turns out in this case that two of the lines have done that, the bottom two. And of course, if any possible line is capable of doing this, then it must be an invalid argument. So that's how we deal with indirect truth tables. If you have any questions about this, feel free to contact me. I'd be happy to walk through it with you. Other than that, just practice, practice, practice. The more the merrier, the better you'll get at it.